everyone how to use Onshape. And today we're covering mostly the importing and exporting and how to do assemblies on Onshape. Last week we went through how to design a part in Onshape. If you did miss out on last week's workshop, we do have a YouTube account that has the videos on how to make all of the parts. So yeah, we could probably skip over this slide. But quick introduction onto Onshape in case you are still unfamiliar with it. It's used for a lot of CAD modeling, and if you're not set up, we'll quickly go through it right now. So yeah, you can go onto onshape.com and you should be able to access it from there. One thing to note is to make sure you are in metric units. We do not like imperial units. This is not America. But that should come up when you first open Onshape. And if not, you should be able to go into your settings and change it. But yeah. So I'll probably start with first you have to create a document, which for today is probably fine. Like so. And then, yeah, you should have a screen somewhat like this when you open it up. And then, yeah, Onshape's just fully cloud-based. It's essentially SolidWorks, but significantly easier to collaborate with other people on. So if you're doing a group project of any form, I would highly recommend doing it on Onshape instead of SolidWorks, because SolidWorks is very terrible in that. I've had experience with both SolidWorks and Onshape is far better. And then quick rundown on the area or what your screen looks like in case you're still a bit unfamiliar. The main bits that you'll need is the feature toolbar, the graphics area, sometimes your view cube, your feature tree, and your tabs down the bottom, which you can create and edit from this plus sign down here. And you can also make folders down here too, if you want to be a bit organized. Yeah, just a bit more info on feature tree, which as a heads up for later, if you import stuff, we can tell if you import stuff or if you actually make it. Just by looking at your feature tree, if we can see all of the steps you've taken to making your part, then we will know that you actually made your part instead of importing it from somewhere online. And then these are the different toolbars you'll see. Usually you'll see parts or sketch, which is what we saw last week a lot of. When we get into assembly, you'll see this new toolbar down the bottom, which is partially hidden, but it consists of a lot of different mating types, which depends on the access and movement of your parts. And then just a recap from last week, if a part is defined, it should be fully black, like the one on the right here. And you can use the dimensions tool in order to go from undefined to defined. And then, yeah, so when you import parts, it should come up in the top part here. And then when you mate two things together, the mating component should appear in the mate features section below it. And this is, yeah, the feature tree, which should be on the left side of your Onshape. And then, so we will be assembling all of our wind tunnels. Last week we went through the outlet part here. Unfortunately, we do not have enough time to go through CADing the rest of them, but if you want to fully CAD the wind tunnel yourself, which if you are in peer mentoring, you will be, you can watch the videos on YouTube, which I think there should be a QR code on the next slide or something. Yeah. If you want to go to our YouTube account, that's the link. That should be the QR code to it. And it has how to CAD all of the different parts for a wind tunnel on there. So if you would like to either CAD one yourself in your own time and manufacture it, you're welcome to. Otherwise, yeah, today we're going through how to assemble all of the different components that was found. Yeah, so today we'll be giving you all of the CAD parts already made. So just the info on how to kind of export a part. I'll actually demonstrate it, but let me find a random CAD part. I'll just do this one. So down the bottom, obviously there's lots of different parts, which we'll just pick this one for now. You can click on export, and then you have different options. Usually, for the most part, you'll probably be exporting it as a step file. If you are exporting it to, say, SolidWorks or a different software to CAD on, you can export it as a SolidWorks step file. Otherwise, if you're going into manufacturing or something in the next stage, we probably recommend exporting it as a step file. But yeah, and then download. If you want it to be particularly oriented altogether, you can pick it as an y-axis up. Otherwise, if you have it a specific way, then you can make sure it's unselected. So when you import it elsewhere, it's in the axis that you want it to be. But yeah, and then it should then download after that. Yeah. That's what I went through. Okay. If you are able to scan, you can scan the QR code, but I will right now send everyone the CAD from the attendance. Did anyone not fill out the attendance who needs the CAD? Okay. Okay, quickly fill out the attendance if you have not, and then I will send the file that has all of the CAD components over. Yeah, but then not everyone has access to. Yeah, they have to verify. Yeah. But I'll send it from the Aerosoc account, so yeah. Hmm? Yeah, but not everyone has the CAD. So we're sending them all of the CAD components. Yeah.
Video's done, by the way. I'm gonna go ahead because like my
I think the dart has. Actually, yes, it should. That should. Yeah. Because you have your own email. Okay, there we go. If people would like to check your emails, you should have gotten an email from the Aerostock account, which has a link to the drive that has all of the CAD files, which you will need for today's assembly. Yeah. If you are stuck with downloading anything, please put your hand up and people will come around. I'm getting it. Yeah. Yeah, people should be checking email. Okay. Does everyone have the CAD files downloaded? Yeah.
Yeah. Once you can see the CAD file drive, can you just all download it?
Excuse me, everybody. Okay, so an email should be sent to the email that you use to attend to put in your attendance, and that should contain a Google Drive of the CAD.
Yeah.
Yeah, so you will be using that CAD to assemble for this workshop. So please check your emails if you have it, and if you don't, please raise up your hand, we'll help you out. Thank you.
Yeah. Yeah.
Just be loud.
Yeah.
I'm supposed to sign your attendance. Okay, tell them that we'll only give them a few more minutes.
Yeah.
Okay.
We'll give you guys like 3 more minutes to make sure it's fully downloaded before we move on.
My enunciation. Please. Please, I do your email. Thank you. I went to a British school, so like usually when I present, it does come out. Like you know how I say it's like
Anyone from Adelaide has
a bit. And like I feel like Melbourne people sometimes. Not my boyfriend. He sounds bogan. I love him, but he's a bogan man. Sorry. I'm pretty much dating a white guy.
close enough.
Close enough. It's an Oxford study. I'm really excited tomorrow because I'm setting up Oscar and my friends. I'm really excited. Wait, Oscar. send me what you're wearing tomorrow. Just so I can, because you have to look good. Yeah. I want you to look great. Okay.
You have to
Elevate it.
yeah.
Wear like a nice cologne or something like that. I'll bring my perfume for you. Don't worry.
Wear a full suit. Go to really impress. Okay, guys. Is everyone ready to move on to the next component? Yeah. I don't need another microphone, but okay. Okay. So now we are going to import all of our parts into Onshape. So here we go. Actually, I need to import. Actually, okay. I have already imported them here, but so basically you need to go down here and click import. And then you should be able to import all of your parts. Hopefully they're in your download folder. But yeah. I will leave you guys a couple of minutes to get that done. Yeah. Yeah, what?
Do you want a bit of help? You paste it. Should I? Okay.
Oh no, I'm inputting the rest of them here. They should be in here. Also to note, they will probably create a folder called imports with all of your CAD imports in it. So if they don't appear immediately, that will be where they are located. I'll probably give you guys a couple minutes to get this fully uploaded, but if you have any questions or are stuck, please put your hand up. On the slides section.
It's just import appearances, right?
Yeah, whatever the default import is. All of them. Make sure to import all of the parts as well. So we are assembling the whole wind funnel. Don't just import one. Make sure you import all of them.
Wait, that's Yeah. Hello, everyone. Wait, can I just get a hands up of who's managed to import everything? All right. Nice. So basically, after we import everything, we're going to do the assembly. So assembly is basically where you like put everything together and make sure like things don't move around accidentally. And yeah, to start off with assembly, we're just gonna come up here. Actually, you see an assembly tab down here. You should already have it. So just click on this, and you're gonna come up here to insert, and you should see basically all the parts that you have imported, and you can basically click and drag everything into the workspace here. So yeah, we'll go ahead and do that. Also, another note, Aaron, for this flat part here, you have two of these, but there'll be one which has a side length of 54 millimeters and one a side length of 56 millimeters. So for the 54 millimeter one, you actually need three of those. So yeah, it should be the gray one, but it's good to have a check to make sure it's the right length. Okay, everyone, once you have all the parts here, you can basically just click and drag on them to move them around. And you can also click on them and you have this like, I guess axis that shows up. And you can use this to basically move parts more precisely and to rotate them. So for example, this part here, it's not rotated the right way. You want it vertical. So to do that, you can just drag on this and just rotate it by 90 degrees. And yeah, these flat plates, you also want them to rotate them 90 degrees as well. So you want them in this orientation. Okay, and after this, basically, once you have everything in the right orientation, we're just gonna basically drag things around to in about the right position. And then after that, we're gonna do the mates. If you want to rotate the camera, you use right click. Yeah. continue? No. Yeah. All right, everyone. Yeah. Can I just get a hands up of like who's got the parts in like close to or about the right position? Huh? I like if they're like sometimes they don't face yeah, like if they like
Yeah, but I don't think they know.
yeah, that's the next step. We have like 1 hour. Should be fine. Yeah.
Just go through kind of where it needs to be.
Okay, let's start from this side actually. Okay, now we are going to start doing the mating, basically fixing everything together. So if you look up at the top, there's all these different types of mates. This mate connector, we won't use this one, but this fasten mate, revolution, slider, all of these. So we're going to be using the fasten mate. So the first part we're going to do is basically this outlet and this transition piece. So to start off with, click on this fasten mate and click on like an edge here. So once we've got this, we're gonna rotate our camera around and click on this other edge here. And this will basically fix those two pieces together. Yeah. So go up here, fasten mate, and then as you like move your mouse over the like outlet, there'll be a bunch of different positions. We're gonna use like this corner here since they'll basically center this mate. So click on that with left click, and then use right click to rotate your camera around. And then you want to basically mate it to this position on the transition piece, and then just left click on that. So yeah, just left click on one side and then left click on the other piece you want. And then once you got that, you can just press this tick here, and yeah, these two pieces are now mated together. So you can like drag these two pieces around, and you see that they stay together, which is exactly what we want. Yeah, I'm gonna continue with the other parts as well. So for these side pieces, we're gonna go up to fasten mate. Oh, fastened mate. So this top one. You can also press M. Yeah. S- Yeah, so what, I might just refresh. So yeah, in terms of what edge you want to select, you just want to make sure that like there's also a corresponding edge on your other part, and just keep that consistent. So like for example, we have this outside edge here. If you click on that, and we just have to find like this exact corresponding part, well, corresponding edge on your other part. Also, another note is that the order in which you click does matter. Basically, the first part that you click will be moved, and the second part that you clicked will basically stay in place. Oh yeah, we're also making a wind tunnel here, and we want to be able to put stuff in. So just as a note for everyone, this blue piece, you see this notch on like this transition piece here? This blue piece basically has to like fit into that. It kind of slides in like that when you actually like use the wind tunnel. So yeah, just make sure to put that in the right position. So yeah, I'll just show you again. So go to fasten mate, click on the corner, or well, not the corner, the edge, and then click on the corresponding edge, and then that will just fasten it. Yeah, and feel free to basically connect everything together now. Yes. Yeah. What do I do with this one? No, I can just click that one. What was the difference from last time? As in, like, what made it different? Yeah.
They're watching the videos.
Okay. They're watching the videos. Yeah. How's the rest?
roll their bell. Because yeah, essentially they closest thing to sonar without losing volume. So I would express the second one because we are working with such fine. Squares are also good. But generally we use squares there because they make it for a real life. It's just a final kind of jump. The main work is being done with we don't need them there. We only need F4 to run it before we hit the so like yeah, the fair enough is yes. So like what's the other for all kinds of stuff. It's like negative. So it's like maybe it's you want the main selling changes behind after the store. So if the store is that region, it's not HI machine. Also the SMB. It also creates like the number so for the game. Secondly, really we actually need very much and then yeah, yes, the business is operating inside the in my spot and just do it. If you increase the for a bunch of sanctions. I think in the why like for us, if you put the settling change at the back, you put it after what we're testing. Well, even fine. Again, Samba. Can I get that? Actually, UK, so I was asking. They're not firing.
Okay, hang on. I've been doing like a lot of edge mates earlier, but just for your information, you can also mate faces to other faces as well. So if you want to do that, you can just like you have to kind of zoom in a bit more, but you can just click on the face and then click on the like other face. And that's well basically the same thing. But in this case, you're selecting the face instead of an edge. So that's an option. Just make sure that like this thing doesn't come up, because if that thing comes up, you're selecting an edge. You have to like zoom in on this one. Oh yeah, and if you accidentally like clicked on a place which you're not meant to click on, like here, then you can just like press the delete here, or you can just use Control Z and just do it again. Oh, yeah, like that. It's not right. All right. All right, and yeah, finally, if you want to like have a section view, like what you might have seen before, you can go up to like this like camera and render options on the side, click on this, and then click on section view. Wait, yeah, and then select the face, and then you basically can drag this arrow backwards and forwards to like change the section view. You can also use this to this like circle on this side to rotate the section view. And yeah, should look like this on the inside. All right. All right. All right. I'm just gonna kind of give an explanation now on how this wind tunnel actually works. So yeah, Nat's gonna draw something out. But basically, we've got a few parts here. We've got the inlet, and then we've got like the settling chambers, and then we have the outlet, and this area where you put the parts in the middle. So to actually generate the like wind or create the airflow, what you're gonna have in the end is like a fan here, and that's kind of gonna like suck air in. Now, the reason we don't put it at the front is because behind the fan, it's gonna generate like a lot of vortices, a lot of turbulence, and yeah, that's not good if you want to view streamlines. Yeah, so the inlets at the front here, you kind of got this like hexagonal shape here, and this basically ensures that the air flows like in a laminar fashion and there's no like turbulences or anything like that. And yeah, this hexagonal shape just happens to be the best shape to do that. It's like very close to a circle, and you can also tile it. At the back here, so these two are your settling chambers, and they basically ensure that the flow is laminar. You've got another one back here, and this one is basically between like the front here and the back here. Like any like imperfections or like turbulences will like might grow or like get carried on here, and this just ensures that it is like perfectly laminar as well. So yeah, it's basically like kind of like a two-step process. And then after that, the air goes into this section, and this is where you want to put your test sample in. So yeah, anything like an airfoil, a car, a mini like model aircraft, whatever you want. And yeah, and then after that, the air just like gets sucked out the back here, gets sucked out through this outlet. Yeah, so the reason why we have this like kind of like decreasing decreasing area is that it increases the airflow speed, and that is what we want. Now I've mentioned this before, but well, you can't really see it in this section view, but there's this blue piece which you can basically like slide out, and that will allow you to put your test sample in. Now, if you've seen those like cool streamlined images, like where you have like, yeah, like air going over like a car or air going over like an airfoil, and you kind of see those stripes. How you get those is basically at the front here, you kind of have like a smoke like generating machine, and they'll basically create those like streamlines that we see. Oh, yes. So there we have a very nice drawing of the wind tunnel, and you can kind of see those lines going like left to right are the flow lines, and yeah, you can see like kind of an airflow there. So yeah, that's basically how the air flows through the wind tunnel. Oh yeah, and another consideration when you're actually designing your own wind tunnel, when you're making that, is that you see how like there's not really any sharp edges here, especially out at the front, and that's to ensure that there's no what's it called? There's no flow separation. Yeah, because like if you have flow separation, that's gonna create vortices like here and like there, and that's not gonna create a very like good flow. So yeah, just make sure that when you're designing your like wind tunnel that everything's nice and smooth, especially at the front. At the back, you want it nice and smooth as well. Yeah.
All right, let's see if there's anything else I can add to that. Andrew did a pretty good job getting most of that done. So, the biggest thing that we have to consider when you're making your own wind tunnels as well is kind of any specific points where you're going to experience a lot of turbulence and or vortices. These can specifically be in areas where you're kind of going from different areas. So, for example, this L shape right here, right behind it, while typically your airflow, I think that Nat has a good diagram up there. While your airflow typically will go in a straight line, within those corners, you're going to develop some sort of vortices, if not turbulence, which screws up the rest of your CAD design. So when you look at what we've got in the wind tunnel here,
a lot of this design is based around how can we mitigate those issues with the wind tunnel. That is the same with how we've designed the inlet and outlet. The inlet is specifically designed to give us the acceleration of airflow using the shape while not completely destroying the entire geometry of the airflow as it travels into the second settling chamber. So you can see right here, if we were to go with something straight, we would be pushing air coming in on the edges into an angle they don't want to be at, creating vortices. If, for example, this was to be shorter and we would have an S shape, which is more like this, the angle here would make it too strong, and for the same reason, you would end up creating areas where airflow is getting constrained and you are losing efficiency, essentially. That is why when we do CFD simulations or we do some sort of testing, there are things that we look for when we develop any sort of airflow design or airflow system and make sure we design around it. It's the same with the outlet here. So if we look at the outlet right now, this outlet could have technically been shorter, it could have technically been longer, but what we wanted to do with this outlet is essentially decrease airflow by changing the size of the hole first at the inlet and the outlet of the outlet, and then also adjust the geometry to fit. So we have to always be considering how airflow is going around these things. It's fun. Andrew's covered most of this, to be fair, so as long as you guys get a general understanding of how it works, then I'm happy. So anything else we need? When we look at things like our honeycomb design, or we look at things like the squares, you may be asking, like, why do we put the honeycomb in a certain area? Why do we put the squares in a certain area? There are a couple reasons behind that. So the honeycomb is specifically placed before we accelerate any airflow. You can kind of see that airflow will be accelerated as we go into the inlet, sorry, which allows us to generate a greater velocity. But if we were to place this main settling chamber at the back of the inlet, what we would create is more turbulence and more vortices. This is because turbulence and vortices are accentuated when the airflow is faster. So our main settling chamber is placed at the beginning. We have a finer one down the end, which is just for any more keepsake stuff. Generally just lets us make sure that our airflow is going to be neat. Otherwise, most of the airflow stuff is those two plus your fan. Specifically, sometimes people will make certain fans that reduce turbulence around the wings or around the wing tips. Other people will just be like me and be lazy to use a PC fan. And that's completely fine, because if you just accelerate air fast enough, it'll be fine. But, for example, I think that's drawing now. If you increase your turbulence, you're not going to create a good visual for your airflow. A lot of what this wind tunnel is, because it does not use quantitative data, is just being able to visually inspect how airflow flows around certain objects when we get to our testing area. If we do not consider how turbulence or vortices are developed in the inlet, in the outlet, and from the fan, this is what you're going to get. So we hope that with a wind tunnel like this, you'll be able to avoid those issues completely. Yeah. And I believe a lot of you guys were working through the assembly, which is really good. Really happy that all of you are at least having a wind tunnel put together on Onshape, which is great. I don't really have anything else to say. So I think that's all. This wind tunnel has been made. A lot of you have seen it at the O-Week store. There's a mini one here, but it was based off of a larger wind tunnel that like a few of us made last year. Which has a few videos somewhere on the internet I don't exactly remember. But again, it's just an interesting concept that we can learn, and I hope that you guys at least took a little bit out of our little rant today. Yeah, sure. Okay, sure. So that was honestly going to be it for the CAD workshop today. We've gone through practically everything that we wanted to go through for this couple of workshops. I'm going to quickly put out a Q&A if anyone wants to ask questions about the wind tunnel design or anything of the sort, and then that's going to put up rubric membership